I'm Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about problem solving on Posix signal functioning and semantics. That means portable operating system interface of the signaling functions and semantics. So how can you resolve the problems in a Posix signaling, the functioning and semantics? Here is the topic is Posix signaling action, sig action function and semantics, portable operating system interface. Here is the question arise in this the problem is how to recognizing the signaling functions that calls the Posix signal functions. For that now we can recognizing the signals means the signaling the functions in a portable operating system interface that can be used to install a new signal handler. That means now we are utilizing the signal handler. By utilizing the new signal handler now, so we can handle the signals now. We can specified the signals can be handled. However, the more robust and recommended the approach for signal handling while communicating data from server to the client or client to the server. Now we can use the portable operating system interface. With help of this the portable operating interface now, these are the compliant the systems and signaling action functions can be performed with help of this Posix. So any signal actions can be performed. Generally, the signal the functions can be thought of as a simple interface that ultimately calls the signal actions behind the scenes. Here is for that handling, signal handling, the code is recognizing the signal of the function first. We have to recognize the signal of the functions. The signal function now which is used by using the header file hash include signal.h. So all these other code can be stored in this header file. Void handler, that is a int signal number. Signal the handling code, that means int the main, signal integer int and handler. So the interruptions, if any interruptions is arise while transmitting the signal, so that can be handled by using the signal handler and returns the 0. Implementing signals using the sig action. Here is how can the implementing the signaling the functions by using the sig action. Here the sig action which is providing a more robust handling mechanism. It is a more robust handling mechanism, so that can be implemented in a C language or Python, so C++, Java, any programming language. Now in a C the language now, if we see the implementation in a C language is, so these all the header files include signal.h, include stdio.h, include std lib.h. Void handler, signaling the handler, that is enter signal number, print to catch the signal and the signal number which the signal is coming. So while the transmitting the signal from client to server, here we have to give the some numbering, signal numbering. Best example is railways now railway signaling, while moving the rail trains from one station to the another station, so we'll give the other signals. So that is a sig number, signal 1, signal 2, signal 3. So whenever giving the other signal now, immediately the train will be at the stop. Whenever we'll give the some signal, red signal, so the train will be stop, and a green signal, if you give the green signal now, the train will be at the move. So this is the number of real-time other applications now. We can use these SIG action, this handler now. We can use in a number of real-time other applications. Here, wrapping the signal number into the signal handler. So once if it is a wrap the signal number and signal handler now, the SIG actions SA.SA handler. So this is the signal handler now. Signal empty set underscore SA mask SIG action. SA means here SIG action masking the signal action. So yes, the SA flag, that is equals to SA restarting the other functions if it is interrupted by the handler. If the signal action, that is signal number and signal action null, if it is equals to -1, now which the signal action which gives the error. If the error is given, here is once the error of the signal is coming to the particular signal workstation, immediately the actions can be stopped. The working actions can be stopped. In example, in railways, Indian railways, if the signal action is a failure, immediately the trains will be stopped, which won't run the other trains when the signal action is a stop. If it is a signal action is a fail, the trains won't move. Whenever the signal actions are working, then only the trains are moving from one workstation to the another workstations. Int main signal wrapper, that is a signal int handler. Next, while if it is while 1, by default value 1, which is the pause waiting for the signal. Here, any action is a fail, now which is waiting for signal. Once if you give the signal, then only you can move the data from the server client to the server or server to the client. The data movement can be done. Once if it is waiting, if it is the fail, we have to pause, waiting for the other signal. We can't move the other data. We can't transfer the other data from one device to the other device. Here is the signal action, generally SA, the handler, signal handler, now which is the pointer to the signal handling function. SA mask is a additional signals to block while handling these other signals. That means SA flag. So special other flag. SA flag is a special flag. SA restart to restart the interrupt system calls. SIG action function. SIG action function, that is a signal number, SIG actions null. So these are the SIG action function now, which is this function, whatever the function now we are using. Whenever the signals, whenever it is the working condition, then only the SIG action function can be the run, which is sending the new signals. Once if it is activating, setting the new actions for the signal number. If you set the new activation to the signal number, then only which sends the signals to the client. Then if it is the client receives the signal, then which transmit the data to the other server. Otherwise now which is in holding, which is in waiting up to getting the signal. So the third parameter is used to save the old actions, which is the null. Here, because we don't need it, it is null, we don't need. First, error handling. Error handling, that means if SIG action is a fail, if the signal action is a fail, it prints an error message. It prints an error message and exit the program. Here is this the signal wrapper function now, which is the demonstrate how the signal could be implemented using the SIG actions and providing more control and reliable in a signal handling. So enumerate the question now. Next question is enumerating the Posix signal segmentation. How we are going to enumerating the Posix portable operating system interface the signals the segments. Posix the signals are generally we are used in a Unix operating system for inter-process communication. Inter-process communication. That means one processor is working on one network, another processor is working on another other network. So one network to another network, that is a public network to the private network. So in this processing communication, generally these are the Posix signals can be utilized. Here these are the Posix the signals now which is handling the signals and transmitting the data. If any errors are arise, it stops the transmitting. Data transmissions can be stopped. Posix signal segments, which is defined how signals are sent and received and handled. Here is the detailed the enumeration of the Posix signal segments. Posix signal segments. Signal types. Here is the standard the signals which is defined by the Posix standard. Example signal SIG interrupting signal interrupting and SIG term signal termination, SIG kill signal killing, SIG USRI, etc. So these are all the standard signals that can be utilized in a Posix signal semantics. Real-time signals. Real-time signals are in a extended signals which is extended of the standard signals. Here is what we are doing, the additional features. What are the additional features now we are using? So SIG RTMIN and SIG RTMAX, minimum signaling and maximum the signaling real time. In a real time signal, minimum real time signal, maximum real time signals. So these are all the extensions of the standard signals. Signal delivery generally here synchronous signals, asynchronous signals. Generally we can categorize in a signal delivery two types. So that is generated by the process itself due to the certain errors. That is a SIG FPE, that is arithmetic error. SIG SCGV, segmentation fault. Asynchronous signals. Asynchronous the signals are generated by the external events. For example, SIG INT, interrupting from the keyboard. SIG TERM, that is a termination request. Termination of the request. Here is the signal handler. So by default, predefined the actions that can be associated with the signal, which could be the termination, ignoring the signal, and stopping or continuing the other process. User-defined handlers. User-defined handlers are the custom functions which will be defined by the user to handle the specific signal using the signal or SIG actions. Signal masking. Here is signal masking means here blocking signals. A processor can block the signal. A processor can block the signal using SIG pro mask to the prevent them from the being delivered until the unblocked. Signal mask. Signal mask means here set of signals currently blocked. So these are the signal or the masking. Signal set. Signal set, what we are doing now, we are setting the signal. That is so data type is used to representing the set of signals and signal handling mechanisms, signal functions, signal action other functions. Here is the signal functions, what it is doing, simplified the interface for setting the signal handler, and SIG action function, more advanced the interfaces that provide the greater control over the signal handling behavior. Here the signal actions generally we are utilizing signal action handler. These are the signal action handler, so which specifies the signal handler functions are predefined functions. With the predefined the functions now, we can that is declared and storing these data, whatever the library data in a header files. So the predefined the actions, that is a SIG the DFT SIG IGN. Signal actioning sig SA underscore sig actioning, which is a alternate signal handler function. So that can be used when the signal flag is set. Whenever the signal flag is set, so it can be used. Flags to modifying the signal handler behavior. For example, SA restart, SA no CLD stop, or SA sig information. SA mask set a set of signals to block during the execution of the signal handler. Signal queuing, real-time signals. So generally can be queued if multiple signals of the same type are sent. Each signal can carry the additional data here. Same type is, now we are sending the same type of, so that can be queued. Queuing the signal, same type of the signal can be queued. Multiple same type of signals. Signal safety. Signal safety, what we are doing, asynchronous signal safe the functions a limited set of the functions so that are safe. So to call from within a signal handler. Example, exit sig pro mask writer. Next, sig pending, signal pending, which retrieves the set of signals that are currently pending for the calling process. That is a signal pending. And signal rising. Signal rising, generally we are utilizing the killing the signals, rising the signals, the queuing the signals, and process the signal the handling. In a signal rising here, sends the signals to process or group of the other process. If it is any damage during this the group of the process, now we are to the particular the single process, if any issues are arise, so that the signals can be killed while transmitting. And rising means sends signals to the calling process. If you send the signals to the calling process, now we can call it as a rising the signal rising. Signal queuing means here sends a real-time signal with additional data. Same as the multiple of data we are going to sending, so it will be queued. INIT and init process or group leader, which is specifying the sig child signal as the child. That means the processor as the child with the child as the process termination. Child signal child process, which is indicate the key term as a sig CHLD. So when a child process is that terminates. Here next the processing group, handling of the process, the group of process can be handled that become the ARPAND due to the termination of the parents. We can say it as that is the ARPAND group process group. Here is the code here for the Posix signaling function implementation and semantics using the C language. Now we are handling the signal. The function is handler int signal number. With help of this single signal number, we can handle the signal 1, signal 2, signal 3. Number of other signals can be handled and catch the other signals. Signal wise we are going to catching. So main is this is the declaration, that is Bayesian structure. Signal actions can be declared. SA.SA the handler can be declared. Signal the empty SA.S mask, it will be declared. SA the flag SA restart will be declared. Here if the signal action, that is SIG INT at the ampersand SA null is equals to -1. So error, that is a signal action exit at the failure. So print, we are printing press the control now, which is generating the signal. Here is while if it is any error is there while transmitting the signal, now pause the signal. Once if you pause the signal, now we are waiting for the signaling. Here in this the example, now the signal action function is used to set the custom handler for the signal interrupting, demonstrating some of the core Posix signal the semantics in a real time. Here for that the textbooks are these are the textbook for this other topic, Advanced Programming in a Unix Environment by Richard Stephen. And reference, this is a reference book, Linux Programming Interface, Linux and Unix Programming Handbook. So this is the reference for this Posix signaling action functions and semantics.
Like, share and subscribe. Hit the bell icon for more updates.